Okay, I think I'm recording. Let's get my face out of the way. All right, this is your Chapter 6A bonus assignment. So you need to do this to try to review for the Chapter 6A test. And this is your key. So please do this and show it to me before you do a retake. Okay, so some of this is review from prior units. Section 6.1. Ask question 1, what kind of elements are present in ionic compounds? All right, ionic compounds are a metal plus a non-metal. Okay, or, anything that's a positive with anything that's a negative. So those could be polyatomic ions also. But basically, it's from this part of the periodic table and this part of the periodic table. Okay, and you need to know that for this unit. All right, covalent compounds are non-metal plus a non-metal, so two non-metals. Non-metal plus non-metal. So that's over here, two of these things in a compound. All right, the word electrolyte means it's some kind of compound that can conduct electricity. So the things that can conduct electricity are ionic compounds. Because when they dissolve, okay? All right, so let's look at this table, okay? You have to be able to look at a formula and tell whether it's ionic or covalent, okay? So the way to figure that out is by knowing that ionic compounds have a metal and a nonmetal, and covalent compounds have nonmetals plus nonmetals. So in the first one, NaBr, sodium is a metal, Br is a nonmetal, so that's ionic. All right, and ionic compounds are electrolytes. Okay, because they're going to give you ions when you dissolve them, which can conduct a current. All right, CH4, two things that are nonmetals, so that's covalent. All right, those are non-electrolytes. All right, you do not get any ions. So no current, no ions. All right, this one, that's actually sugar. There's no metal in there. So that's also covalent. All right, it's also a non-electrolyte. Electrolyte. All right, no ions, no current. You only get ions if you have a metal and a nonmetal. All right, this one, magnesium chloride. Magnesium is a metal. Chlorine is a nonmetal, so that's ionic. All right, if it's ionic, it's an electrolyte. All right, because it gives you ions, which can conduct a current. All right, so number 5. When ionic and covalent compounds are put into water, they dissolve in different ways. When ionic compounds dissolve, they break apart into ions. When covalent compounds dissolve, they stay stuck together. They just get surrounded by water. All right, so this says for the ionic compounds in the formula above, so question number 4, write the ions that form when they dissolve in water. So there were only 2 up here that were ionic, sodium bromide, magnesium chloride. All right, and if I were to put sodium bromide into water, I'm going to draw a little picture right here. All right, solid sodium bromide, you put it into water, you dissolve it, it's going to break apart to sodium ion with a +1 charge and a bromide ion with a -1 charge. So the charges, remember, you can get from your periodic table. Here's sodium, go up to the top, there's a +1 charge. Here's bromine, go up to the top, there's a -1 charge. So it's really, really, really important that you write these charges. So if they don't have charges, they're not ions. If they're not ions, they cannot conduct a current. All right, the cation is the positively charged ion, so that's going to be sodium. The anion is the negatively charged ion, so that's bromine. Okay, those are just vocabulary words. All right, magnesium chloride. If I take some solid magnesium chloride and I stick it into a beaker full of water, it is going to break apart into magnesium ion, which has a +2 charge, and 2 Cl ions with a -1 charge. Because that formula has a 2 right there. So I have 2 of them. So you could write that way or write 2 Cls. So here the cation is magnesium, okay, and the anion is the chloride ion. Okay? All right, I'm going to stop on that one.